Okay. What else is on here? Okay, physics questions. You should be onto those worksheets. So there's actually one's repeated.
I'll be right back. My camera isn't working, so I have to refresh the screen or whatever.
Okay. Okay. Did you look at the girls? Did you look? Hi, Justin. Did you look at the questions yet on the worksheets? Mary, Dylan.
No, I never did, really.
Okay.
I just did the assignment, and then I just, yeah.
All right. Well, we have to get through those 3 worksheets this week. All right. So let's look at the first question on the worksheet. Let's go through it first. We'll go through the first. I'm going to go through the first 3 questions with you, and then we'll go from there. So pull out your worksheet. It says chapter 18 at the top of it. All right. As the heating element in a broiler dissipates 3 kilowatts of power as heat when connected across a 120 volt line, what current is in the element? What is the resistance of the heating element? What is the cost for 2.25 hours of operation at 9.5 cents per kilowatt hour? How many kilocalories? All right. So first thing, go ahead.
I'm not sure where you are. Sorry. I don't. Same.
The worksheets at the end of the package. There are 4 worksheets. And the one that I am using is the one that says chapter 18 in small print at the top of it. Find it? It's flip to the end of your package.
Okay. Okay, got it.
You got it?
Yeah, sorry about that.
That's okay. No worries. Okay. So the heating element in a broiler dissipates 3 kilowatts of power. So what we want to do is I'm going to change power. So that's 3,000 watts. Is disconnected across a 120 volt line. And it wants us to find the current. What is the current in the heating element? Okay, so I need I. So take your power and divide it by your potential difference.
25.
Yep. So 25 amps. Now it wants the resistance in it. So rather than using the current, I mean, you could check it after, but this is what I would use first. P equals V squared over R. So R is equal to V squared over P. So 120 squared divided by 3,000.
4.8.
4.8 ohms. Okay. Now just have a look here. I have V and I. I could take 120 volts divided by 25 amps, and it should give me the same answer. So you could use that as well. It says, what is the cost for 2.25 hours of operation at 9.5 cents per kilowatt hour? All right. So the cost is equal to 3 kilowatts times 2.25 hours times 0.095 dollars per kilowatt hour. So 3 times 2.25 times 0.095.
So if it was just asking for like calories, would you switch your kilowatts into?
Yes. Yeah. Otherwise you're solving this. See, to make the fewest amount of mistakes, I always switch everything into their base units, and that includes kilograms. I'll switch it into grams for this one and work it all out, and then at the end I'll divide by 1,000 to turn it into kilowatts or kilograms or whatever it is, kilocalories. Okay, so use them all as base units for right now. All right.
Okay.
And then it says how many kilocalories of heat are produced during the 2.25 hours of operation. Okay, so I need my Q. So I'm going to use my I, 25 squared. My R is 4.8. My time I have to convert. So times that by 3,600. And then divide it by 4.19. Okay, so I convert the time from hours to seconds. So this
I feel like mine's wrong.
What's that?
I feel like the one that I got is very wrong. It's too large.
No, it's going to be very large. 579,000. Nope, sorry, 5,799,522.
Yeah, that's what I got.
0.673. So that's calories. Now you divide that by 1,000. And that's 5,799.523 kilocalories. And that's the right answer. All right.
I'm sorry, I just have one question.
Sure, go ahead.
Because you had it in kilowatts for your first formula, like you have 3 kilowatts.
Yes.
And then, okay, no, never mind, I got it.
You're okay?
Yeah, I got it.
Okay. All right. Let's look at the second one then. An electric heater has an element resistance of 15 ohms. So I've got a heater has an element of 15 ohms. When connected across a source of EMF that draws a current of 24 amps. What is the potential difference across the heater? All right, so that's straightforward using Ohm's law. Okay, so I times R, 15 times 24. That gives me my potential difference, 360 volts. How many kilocalories of heat are produced per hour? So I need the amount of heat per hour. So I've got 24 squared, 15, 3,600. Oops. Over 4.19. So again, that's going to give me calories. That's not going to give me kilocalories. So there'll be a larger number.
My microphone's muted. 7,423,389.021.
Perfect.
calories.
That's right. We'll divide it by 1,000.
7,423.389 kilocalories.
Excellent. Good. And then it says, what is the cost of 2 hours of operation at 8.5 cents kilowatt hour? So we have to find the power then. You can use I squared R, V times I, whatever you want. So I get a power of 8,640 watts. So I got to use 8.640 kilowatts times 20 hours times 0.085.
1.469.
Okay. 20.085. What did you get, Rory?
9.469.
Okay, so I got a little different number than you. So I've got 8.640 kilowatts, right?
Yeah.
Times 20 hours.
Yeah.
Times 0.085.
Oh, 1 sec. I have an extra 0.
Okay.
Well, it's times 0.085, I thought.
0.085, yeah.
Put the decimal in the wrong place, my bad.
Okay, so I end up with $14.69. Okay. All right, girls?
Yeah.
All right, let's look at the third one now. All right. Heating element in a percolator has a resistance of 16 ohms. Designed for use across a 220 volt element circuit. How long will it take to heat? Okay, so I haven't read all the question yet because I want to show you what's happening here. Okay, so here's my output. My output is my 220 volts, my 16 ohm resistance. I need to find my current. That's my output. My amount that's actually being taken out of the output would be how long will it take to heat 1.4 kilograms of water. So 1,400 grams of water, which is one specific heat constant, 1 calorie per gram degrees Celsius. And 18 to 100, 82 degrees Celsius. So they give you the equation there. So my output is Q equals I squared RT over J. The amount that I'm taking from the output is MC delta T. Okay. So when it's all said and done and I mix and match these guys together, all right, so I got to get time by itself here. So that's Q times J over I squared R. And over here, I've got MC delta T. That's my Q. So I'm going to use that cue and put them both together. All right. So my M, 1400 times 1 times 82 times 4.19. I got to get my I, so I need to take 220 and divide it by 16. And then times it by my resistance, which is 16 ohms, equals. Okay? So I end up with 159.01 seconds.
I did not get that. No sec.
Did you use brackets on the bottom?
Yeah.
Did you square the 13.75?
Yeah. Just 1 sec. I'm putting it all back in.
Okay.
Still nothing. I got like 40,000, which is not correct.
Okay, let's try it again. 1400
Okay.
times 82
Okay.
times 4.19
Yes.
divided by,
Yep.
open bracket,
Okay.
13.75 squared.
Yep.
Times 16. Close the bracket and hit equals.
Okay, 1 sec. Yeah, now I got it.
Okay, excellent. Okay. All right, so what I'd like to see, girls, is if you would finish that sheet up today. Go through the rest of it. All right. Any other?
That's number 5 or the backside too?
All of it. Backside too.
Okay.
All right. Any other questions, concerns? Are we okay?